Hello friends, and welcome. Here is a question worth sitting with. What operating system ran the phone in your pocket this morning, the server that delivered your last search result, and the supercomputer that modeled this week's weather forecast? In almost every case, the answer is Linux. And this is not old news. Just 8 days ago, on June 14, 2026, Linus Torvalds released Linux Kernel 7.1, the latest stable version, built by over 2,000 developers across nearly 13,000 individual changes. Linux is the software foundation the modern world quietly runs on, and in this video we are going to understand exactly how it works, from the ground up. Alright, let us start with the basics. An operating system is the software layer that sits between your apps and your physical hardware. Think of it as a traffic controller. Your apps, a browser, a game, a text editor, do not talk directly to the CPU or the memory chips. They ask the operating system to do it for them, and the OS makes sure everyone gets a fair turn. Now, inside the OS, there is an innermost core called the kernel. The kernel is the piece that actually controls the CPU, allocates memory to each program, and talks to devices like your keyboard and storage drive. Everything else in the OS, the desktop, the file manager, the shell, sits on top of that kernel layer. Next, let us look at what makes Linux's kernel special. Here is the interesting part. There is exactly one Linux kernel, maintained openly at kernel.org. Linus Torvalds and over 2,000 contributors worldwide shape every release. But most people never install that raw kernel directly. Instead, they install a distribution, or distro for short. A distro takes the kernel and bundles it with everything you actually need: a desktop environment, system tools, and a package manager, which is basically an app store for your terminal. Ubuntu, Fedora, and Debian are three of the most popular distros, each making different choices about software and defaults, while sharing that same upstream kernel. You can see exactly this pattern this month. Sparky Linux 2026.06, released just days ago, offers kernel 7.1 as an installable option on top of its Debian base. One kernel, hundreds of flavors. Coming up, let us explore how Linux organizes your files. Now let us talk about where Linux stores things. On Windows, you might be used to drive letters, C:, D:, each as a separate island. Linux works completely differently. There is one unified tree, and everything hangs off a single root, written as just a /. Under that root, you find key directories. /home holds each user's personal files. /etc. holds system-wide configuration files, things like your network settings. /var holds data that changes over time, like log files. And /bin holds the essential command line tools the system needs to run. Even if you plug in an external hard drive, Linux does not give it a new letter. It mounts it somewhere inside that same tree. One single organized structure for everything. Let us now look at what happens when you run a program inside that structure. Let me show you what happens the moment you type a command like ls in the terminal and press enter. The shell asks the kernel to create a new process. A process is simply a running program. The kernel assigns it a unique number called a PID, a process ID. Then the kernel scheduler decides when that process gets a slice of CPU time, often just milliseconds at a time, taking turns with every other process. This is multitasking. While Firefox is open and waiting, ls runs, finishes, and exits. The kernel also manages RAM, handing each process its own chunk of memory, and making sure one process cannot read or corrupt another's data. You can see every running process and its PID on your own machine by typing the command ps in the terminal. It is a live window into exactly what the kernel is managing right now. Next, let us look at how Linux controls who can do what. Alright, Linux was built from the start as a multi-user system. That means it needs clear rules about who can access what. Every file has 3 permission sets: the owner, the group, and everyone else. For each set, there are 3 possible rights: read, write, and execute. You often see this written as a string, like rwxrxr, which means the owner can read, write, and run the file. The group can read and run it, and everyone else can only read it. The place where you apply these rules is the shell. The shell is the command line interface, programs like bash, and it is how you talk directly to the operating system. The command chmod lets you change permissions in one line. This model keeps a Linux system secure, even when dozens of users share it. Now let us bring the whole picture together and see why it matters so much in 2026. So let us pull it all together. Linux is an open-source operating system kernel, the core layer managing your CPU, memory, processes, and devices. Distros like Ubuntu, Fedora, and Debian package that kernel into a complete system. The file system hangs off one root. The kernel schedules processes with PIDs and shares RAM between them. And permissions enforced through the shell keep everything secure. Why does this matter right now? The consumer extended security updates for Windows 10 expire in October 2026, pushing a fresh wave of users toward Linux. Governments including Germany and France are actively migrating public offices. And the Kernel 7.2 merge window, which opened the moment 7.1 shipped on June 14th, already has over 7,000 change sets pulled in by thousands of contributors worldwide. Linux is not just the past of computing. It is very much the present and the future. Thanks for watching, and we will see you in the next one.